Welcome to Let's Do It 512. In this LDI, we're going to take a look at how to interpret a box plot with respect to variability. One of the things we're studying here in this part of the chapter is measurements of variability. And so they're going to have us take that for a practical use here by invoking a different type of sampling scheme depending upon what our populations look like. Okay, so in the cases here, population A, B, and C are broken into two strata, stratum 1 and stratum 2. All right, and what we want to do is use the side-by-side comparative box plots from the two stratum from the three populations and decide which type of sampling scheme would we use. Would we use random sampling, stratified sampling, taking sampling of equal size from each of the strata, or stratified sampling where we take more samples from one strata than we do from the other? Okay, so here's the question. For populations A, B, and C, will design 1 and 2 be comparatively effective? In other words, which of the populations would designs 1 and 2 be the same? So design 1 is to take a simple random sample. Design 2 is to take a simple random sample with the same size sample from each strata. Well, the thing to notice here is that in population B, that the side-by-side comparative box plots show us that there is very little, if no difference, between the two stratum. In other words, stratum 1 and stratum 2 really are basically the same. So for this one, the answer is going to be B. And the reason is because there's really no difference between those two stratum. All right. Okay, let's go ahead and get rid of our circling here. Okay, for which populations A, B, and C would design 2 be the best design? Well, in population C, we notice that stratum 1 and stratum 2 are different with respect to their measurements of the center. Excuse me, they're very different with their measurements of center, but their measurements of variability, that is their interquartile ranges, appear to be about the same. And let's take a quick peek at that. Let's draw the length of the line for the interquartile range here for stratum 1. And then notice if we take that interquartile range and we move it down here, by Jove, it looks like it's about the same in stratum 2. In other words, the interquartile range, which is the length of the box, the difference between Q3 and Q1, is the same for both those stratums. So they have the same amount of variability, but on the other hand, if you take a look at their medians, right, their medians appear to be very different from each other. So in that case, it would look like population C would be best for you to take a simple random sample from each stratum, but it's okay to take the same size sample from each because they have the same amount of variability. And now, last but not least, which one would design 3 be the best for? Well, let's use that same trick we just did a minute ago, and let's take a look at the length of the interquartile range on these two box plots. So if we look at the length of the interquartile range on these two box plots, we notice that stratum 1 has a much smaller interquartile range than stratum 2 does. And so what that means is there's a lot more variability in the data in stratum 2 than there was in stratum 1. So in this case, it would be best to use sampling scheme 3 here in population A. And the reason for that is you'd want to take more out of stratum 2 than stratum 1 because you're going to have a harder time getting a good idea what the distribution looks like, or getting a sense perhaps of the measurement of the center when you have more variability in the distribution. Okay. Last but not least, ask which stratum in this population should have a higher sample size, and that would be, we just said that, but it should be, move that down where you can see it, it would be stratum 2. There we go. All right. Okay. Well, the main purpose of this LDI, the thing to get you looking at, is one of the real things you want to catch from this is that a box and whisker plot can show you a difference in variability. Notice that between those two stratum, we see that there was a higher measurement of variability in stratum 2 versus stratum 1. And it also can, let's get rid of some of my extra markings here, it can also show you a difference in measurements of center. Notice that this center is markedly higher than this one if we were assuming that up is positive on these box plots. Okay, so one last question before we leave this LDI. If a box plot is symmetric, can we conclude that the distribution is symmetric? And the answer to this is no. All right. Turns out that if the distribution is symmetric, then the box plot will be symmetric. But if the box plot is symmetric, it's not necessarily true that the distribution was symmetric. I'm going to have you take a look in your textbooks. They got a nice write-up in there on that. And I would highly advise you take a look at that and get a sense of why this is a true statement. Okay? All right, see you all back here for the next LDI.